Um, Hi guys, welcome to Maths and 6. Today we are doing partial fractions, and I'm sure we still have an idea what these are from N5. Okay, so now if you check on your screen there, you notice that some formulas. This is from your formula sheet, so you notice some formulas are still the same; they haven't changed, except formula, the last formula, because in N5 we didn't do any partial fraction with a quadratic denominator, so it's only now that we have that part for quadratic there. We had this formula in N5 but we never used it there. So we will do example of each formula one by one. So we'll do 3 examples, one for the first formula, second one, and third one. So now if you check the first formula there, if you check the first formula, so if I make an example, let's say I have x plus 1 over, so this is when you have a term repeated n times. So I can have, let's say, x minus 1 exponent 4, for example. So which means I'll have a plus b plus c, because it's 4 terms, plus d. So under a I'll have x minus 1 exponent 1. So you're going to repeat this term 4 times, increasing the exponent. So this will be, do you see here I have ax plus b exponent 1, then exponent 2, 3, then until exponent 4, because our n is 4 there. So now the second one here you have, it's more or less the same as number 1. It's more or less the same as the first one, but now you have two different terms with two exponents. So you'll do the same thing. You'll expand the first term 3 times, which is ax plus b exponent 1, then exponent 2, exponent 3, then from which will be a, b, c. Then you continue with cx plus d, which is from d, e, f. So you'll do it also exponent 1, exponent 2, exponent 3. Then you solve. Solving, we will do it, but solving shouldn't be a problem. If you can expand, so solving shouldn't be much of an issue, but we will do it. We'll do other examples and see if we can understand it. Okay, then the last one is if you have uh, the linear terms. So if you check, these are all linear terms. If you have only x, it's linear. If you have the highest exponent is 2, it's quadratic. If you have 3, it's polynomial, 3 and more, which is okay, yeah, we used to just call it polynomial. It's a cubic function. Yes, that's the term. So now if I have a linear and I have a quadratic, so first thing you must do, check if that quadratic cannot be broken down or factorized into other linear terms. So if you can factorize it into linear terms, we know we can just expand it using the normal a plus b plus c. But if it's quadratic and you cannot further factorize it, then at the top you'll have ax plus f. Ax, so if you check everything there at the top, it's like you have the differentiation of the bottom. We know the differentiation of ax plus b will only be a constant. The differentiation of a linear will be a constant, because you're differentiating x. The differentiation of quadratic, if you differentiate x here, you'll be left with x times something, but exponent 1 plus constant, because constant is from, for example, bx. So that's why you have ax plus f. But you don't have to say plus f, because you don't have to wait for all the terms to finish then come back to f. You can say ax plus b, then when you go to the next term, say plus c, because these terms must be, this alphabet should be different. So if this was ax plus b, this one should be c, this one should be d. Then, and remember that it doesn't matter who said a where or b where. What matters is the answer. If my B is on C and your C is on B, then it means what I will get for B is what you will get for C. So that shouldn't bother you how you write it, as long as you write it properly. Okay, but you'll see when we do examples. Let's get started. Okay, so this is the first equation. So I will pick any example. Okay, I think I wrote an example down, because usually if you pick any example and you find out you're just going around in circles. Okay, so this is my first example. I'll use x minus 1 over 2x minus 1 all cubed. Okay, let me use a white pen. So if you have to determine, remember this will be something like this, will be an integral. If they say determine the integral of this, but they will tell you that use partial fractions. Do you see? So we know this rule. You have 2x minus 1 repeating n times, which is 3 times. So we know we must expand it to a 2x minus 1 exponent 1 plus b 2x minus 1 exponent 2 plus c 2x minus 1 exponent 3. Then 3 is the maximum. You end there. So I'll divide this into 2 so we can work out our solution. Okay, sorry about that sound. Okay, so now, okay, but remember when you expand it like this, you don't need the integral sign anymore. You put it back to the integral sign when we are done. Now we have to solve a, b, and c, then we can go back to integral sign. But first thing, remember, first step after here is to multiply by the common denominator. Or if you want to remember it easy, you multiply by the denominator of your left hand side. So if I multiply this side by 2x minus 1 cube, I'll be left with x minus 1. If I multiply that term of a by 2x minus 1 cube, 2x minus 1 will be cancelled, so I'll be left with 2x minus 1 squared. If I multiply b, I'll be left with 2x minus 1, because this cube will cancel that squared. If I multiply c, the whole of 2x minus 1 cube will cancel. That's what I have. So now we must solve for a, b, and c. So, okay, I hope this thing is not, this microphone keeps on moving. I hope it's not making funny sounds. Okay, now remember, the easy way to solve for these constants a, b, and c is to try make some terms zeros. So the only term we can make 0 is 2x minus 1. So if 2x minus 1, if it's the only way it will be 0 if your x is positive half. Because if you solve 2x minus 1 equals to 0, you'll notice your x is half. So if x is half, what happens? If I substitute half for x there, I'll have half minus 1, I'll have negative half. This will be 0 and this will be 0. So which means a will be multiplied by 0, b will be multiplied by 0. I'll be left with c. So I have c. So now we need a and b. How do we get them? So there's no any other term we can make 0, right? So we exhausted all our options for making a term 0. So now we can just substitute any values we want. But always try to work with easy numbers, because I can already see I didn't use a 0. So you should always think of a 0, because 0 makes everything easy. So I'll start. So you should always think of small numbers. So 0 plus 1 or negative 1 plus 2 negative 2. Don't go beyond that. So if I substitute 0, 0 minus 1 there on this equation here, 0 minus 1, I'll have negative 1. If I substitute 0 on that term for a, I'll have minus 1 squared, which will be positive 1 times a. If I substitute 0 here on b, I'll have minus b, then plus c. Now remember, we have c. C is negative half. So now if I solve, let me do it here. If I solve that c, if I take negative half the other side, I'll have negative 1 plus half. So I'll have negative half again equals to a minus b. Then I can decide to solve for a. So I can take b the other side, it will be positive. B minus half equals to a. So this is my value for a. Because I know I have to do simultaneous somewhere. So now let's move on. So now how do we get the second equation? Because if we have two unknowns, we need two equations. So now we substitute another value for x. We can choose 1 or negative 1. But I prefer working with positive numbers. So if I substitute this positive 1 in this equation, I'll have 1 minus 1, which is 0. I'll have a multiplying what? 2 times 1 minus 1 is 1, all squared, which is 1, plus b multiplying 2 times 1 minus 1 is 1, then plus c. So now let's substitute. We said a it's okay, a, yeah, we said a it's b minus half plus b, because we are solving for b, and our c it's minus half. So I hope you can see what happens here. I'll have b and b, which will give me 2b. I'll have minus half and minus half, which will give me minus 1. So I'll have 1 equals to 2b. Then I'll have b equals to half. Now how do we solve a? We substitute a in this equation. We said a it's b minus half. If my b is positive half, I'll have half minus half, which means a it's 0. So I have all my values. I have 0, I have positive half, I have negative half for c. So let's substitute on our integral sign. Okay, so remember we just calculated a to be 0, b to be positive half, c to be negative half. So now if we go back to our integral sign, we had a over 2x minus 1 plus b over 2x minus 1 squared plus c over 2x minus 1 cubed. But now we must put everything under integral and put our dx. See, so we know if a is 0, this term we don't have to include it. 0 over anything is 0. I just substituted it to show you, but next time we won't include it. So now we are left with half over 2x minus 1 squared. Remember, the only time you can use a ln formula is if your denominator is exponent 1. So this is not exponent 1, so the only way is to take 2x minus 1 to the top. So I'll have that half at the top outside, then I'm taking 2x to the top, it becomes negative 2. The same with the second term, I'm taking 2x to the top, becomes 3, negative 3. This negative half is the numerator then. So now how do we solve this? We can see this is u substitution. We can see if this is u, then the derivative for u. Okay, let me do, it's just that it's gonna be long step, but let me just do it. If u is 2x minus 1, then the derivative will be 2 dx. Do you see? But here we have 1 dx, so I can solve, I can say du over 2 is equals to 1 dx. So now let's substitute. Let's go back. I have half, I have u exponent minus 2, then I have du over 2, because we said dx. Remember, this is u exponent minus 2 and this is du over 2. Then we have minus half, we have u exponent minus 3, du over 2. So now quick, this over 2 will make this 1 over 4, u exponent minus 2 du minus 1 over 4 u exponent minus 3 du. So now integrate. If I integrate, I'm adding 1 to the exponent, dividing by answer. So I'll have u exponent minus 1 divided by minus 1, which will make this minus 1 over 4. Here I'll have u exponent minus 2. If I add 1, divide by minus 2. That minus 2 will make this negative 1 over 4 positive 1 over 8 plus c. You see, we are done. Now you can just substitute your answer. Minus 1 over 4, 2x minus 1 plus 1 over 8, 2x minus 1 plus c. That's your answer there. But this step for u substitution wasn't necessary. If you know your u substitution, you can just do it in your head. You know from here I have to add 1 to the exponent. Okay, but first, you know, if you have 2x, then the dx must be multiplied by 2. So you put 2 there, you divide by 2 outside. Or you do it this long way, it's fine. Okay, but what's important here is to calculate values for a and b. How to integrate after that shouldn't be a problem to you, because you've done too much of that in M5. Okay, let's move on. Now the video is already 16 minutes long. I wanted it to be short. Okay, the next one. This is the normal one we know if you have your linear terms. This is linear terms, shouldn't? So I'll just make a quick example. Let's say I have 2x plus 3. Let's say it's over x minus 1. Let's say x plus 3 squared. You see? So which means if I expand this, your x minus 1 is one term and it's linear, so it will be a over. The second one is also linear, so it will be constant over x plus 3. But it's exponent 2, so you must do 2 of them and increase your exponent. Do you see? Then what's the next step from here? Multiply everything by this denominator. If I multiply your left side, I'll be left with 2x plus 3. If I multiply a, I'll be left with x plus 3 squared. If I multiply b, I'll be left with x minus 1 and x plus 3, because that x plus 3 is squared, it will only cancel 1 x plus 3. If I multiply c, I'll be left with x minus 1. So now we can see we have to make some terms 0. So we can make x plus 3 0 by making x minus 3. We can make x minus 1 0 by making x equals to positive 1. So let's see, if x is minus 3, what happens? If we substitute here, we'll have minus 6 plus 3, which is minus 3. This will be 0. Where there is x plus 3, it will be 0. So a will be multiplied by 0, b will be multiplied by 0, so we'll be left with c. C will be minus 3 minus 1, which will be minus 4c. So you can see your c is positive 3 over 4. I hope that's clear. Now, the next one to do is to make x positive 1. So if I substitute positive 1, I'll have 2 times 1 here plus 3. So I'll have 5. Then if I substitute here, I'll have 1 plus 3. 1 plus 3 is 4 squared. It will be 16a. Here we have x minus 1. This will be 0. This will be 0. So that's my answer. My answer will be 5 over 16. Now how do we solve b? We can't substitute minus 3 and 1 again. We already used them. So now you pick any value you want. Remember, always use 0 if you didn't use it, if you haven't used it. If I substitute 0 here, I'll be left with 3. If I substitute 0 here, I'll be left with 3 squared, which is 9a. If I substitute 0 here, I'll be left with minus 1 times 3, which will be minus 3b. If I substitute 0 there where there is c, I'll have minus c. So now we can solve. We know our a is 5 over 16. Our B is what we are looking for. C is 3 over 4. So I'm going to solve 3B quick. I'll use my calculator because you can see we don't have space. So if I solve for 3B, I'm taking 3B the other side. So I'll have positive 9 times 5 over 16 minus 3 over 4. Then that 3 on the other side will be negative. So I'll have minus 15 over 16. Then how do we get B? We divide by 3. So if I divide by 3, I'll have minus 5 over 16. That's my A, B, and C. So we have 5 over 16, minus 5 over 16, and 3 over 4. Okay, so yeah, I hope we can still remember them. So let me write them on the next page. 5 over 16, 3 over 4. Okay, yeah, let's continue. So we had A over x minus 1. So in our A was 5 over 16 over x minus 1 dx plus B. Our B is minus 5 over 16. Remember, this is x plus 3 dx plus C. Our C was 4 over 5. Yeah, I hope I got that right. Problem is I can't go back when I'm here. 5 over 5, 4 over 5 x plus 3 squared dx. Okay, I just remembered our C was 3 over 4. Okay, so now we can see our first two terms. We can see this is the denominator is exponent 1, and your x plus 3 is also exponent 1. It's only x plus 2 plus 3 exponent 2 which is not exponent 1, so which means it's not a line function. So the line rules we're going to use to our first two terms. So for now, let me change that before we apply our line. But first, the important thing to do is you can remove the numerator so that you can be left with something which is easier to work with. Here, if I remove it, I'll have 3 over 4. And if I take that denominator to the top, I'll have minus 2 dx. So we can see it's line. We know the derivative of x minus 1 is 1. So we don't have to do anything. The derivative of x plus 3 is 1. The derivative of x plus 3 is 1 dx. So which means we don't have to do anything. But this is u substitution, this one, because of the exponent. So the first one, let's apply our line. We have 5 over 16 line x minus 1. The next one, we have 5 over 16 line x plus 3. The last one, we have 3 over 4. This is not line, it's u. We are going to add 1 to the exponent. So I'll have x plus 3 exponent minus 1, then divide by the answer, which is minus 1 plus c. That's your answer then. You can simplify if you want, make that negative 3 over 4 x plus 3 exponent minus 1, but that's your answer. Okay, last one. If those two took that long, this one will take quite some time because of the quadratic. Some things are become a bit. Okay, let me see if I have a question for this. I'll take the 2021 July question paper. We'll do the question which was there, and these questions are usually 6 marks each because they take your time. They take most of your time during the exam, so they have too much marks. Okay, now I can't see my question paper. Okay, here. Okay, let me write it here. So you have integral of 3x squared plus 16x plus 26 over x minus 2 x squared plus 3x plus 4. Determine that. Okay, first of all, before you assume this is linear and quadratic, you have to first check if your quadratic can be simplified. So we know the factors for 4, it's 4 and 2, it's 4 and 1 and 2 and 2. So with 4 and 1 we can get 3, but we can't get positive 3. If we use positive 4 and positive 1 we get 5. So we can't simplify this. So which means this is linear and quadratic. If that's linear, for x minus 1, for x minus 2, the first term, because it's linear, will have a over x minus 2. You see linear here, if you check there at the top for linear, we have constant at the top. For quadratic, you'll have constant multiplying by x plus another constant. So this quadratic will have what? The next constant from a is b, so we'll have bx plus c. Then you put that whole there, that whole term there. So now the next step, remember, don't forget to remove this. You'll put it back when you write the answer. Now the next step is to multiply by the denominator both sides. So if I multiply there, I'll be left with 3x squared plus 16x plus 26. If I multiply a, I'll be left with the quadratic because x minus 2 will cancel. If I multiply bx plus c, do you see the bracket? Because it shows that your x minus 2 is multiplying everything. If you don't put bracket, you'll end up multiplying only c. So now we have to solve for a, b, and c. So the easy way where we can start by making x 2 here. If x is 2, we know everything, your b and c will be 0 if x is 2, right? So let's start there. If x is 2, so let's substitute. We have 3 times 2 squared plus 16 times 2 plus 26. I'm getting 70. Okay, let me see. I'll copy it also. Yeah, it's correct. Okay, if we substitute at a there, substitute 2 squared plus 3 times 2 plus 4, we're getting 14. So now solve for a. 70 divided by 14, it's 5. So our a is 5. We are done. Now the next thing we can do you see your b? It's multiplied by x. So which means if I make x 0, I won't have b anymore. So let's do it. Because if we can eliminate something, it makes our calculations easier. So if I substitute 0, that side I'll be left with 26. This side I'll be left with 4a. Your b will be 0, so I'll be left with c multiplying minus 2 there. If I substitute my a, which is 5, I'll have 4 times 5 minus 2c. So if I take 4 times 5 the other side, 26 minus 4 times 5, I'll be left with 6 equals 2 minus 2c. So we can see my c is minus 3. You see, now we have a and c. We are left with only b. And now if we want b, we have to substitute any value because we already exhausted our options of elimination. We used 2, we used 0. So now we use any value. Okay. So let's continue from where we left off. So I will write that equation again. I'll make 2 screens so that we can finish up here. So we had 3x squared plus 16x plus 26 equals to a times x squared plus 3x plus 4 Am I right? Yes. Plus bx plus c multiplied by x minus 2. We already calculated a to be 5. We calculated c to be minus 3. Now we are left with b. So we say now we can substitute any value. We already used x equals to 2 and x equals to 0. But we haven't used positive 1 and negative 1. So let's use 1. So if I substitute 1 on the left hand side, I'll have 3 plus 16 plus 26. I'll have 45. If I substitute 1 here, I'll have a multiplying what? 1 plus 3 plus 4. I'll have 8a. If I substitute 1 here, I'll have, let me do it step by step. I'll have b multiplied by 1, which is b plus c times minus 1, because I'll have 1 minus 2 here. So now let's try to simplify. I have 8a minus b minus c. Okay, now remember we are solving for b, so I'm taking b the other side. So I'll have 8a minus c minus 45. So now substitute. We know a is 5. We know c is minus 3 minus 45. So I'll have 8 times 5 plus 3 minus 45. So we have minus 2. There, that's our answer. So now if we put it back to our integral sign, remember integral sign we had a, which is 5 over x minus 2. Then we had ax plus b. Okay, hold on. Okay, we had ax plus b. B we got minus 2, right? Let me confirm. Yes, ax plus b over that whole quadratic, which is x squared plus plus what? Plus 3x plus 4 dx. Okay, so I'm making an error here. Here was remember this is a over that plus bx plus c, so which means it should be minus 2x plus c. My c is what? Minus 3. Perfect. So if you notice something, because when you get here, if when you use quadratic, when you get to this step, it's always one thing. So if I take out 5 here, you can see I have my limb. If I take out negative here, I'm left with 2x plus 3. Then you can see I have my ln. Remember, for you to use ln, it means at the if you have a function at the bottom, at the top you need its derivative. So that's why this is a ln, because the function x minus 2, the derivative is 1. So the function x squared plus 3x plus 4, the derivative is 2x plus 3. So now we have ln. So this will be 5 ln x minus 2. This one will be minus ln x squared plus 3x. So that's one thing I love about this quadratic equation. It's longer to find this constant, your ABC, but to solve it, it's easier. The values you always get here lead you straight to ln. Sometimes they can be doubled. It can be 4x plus 6. You know, you need to take out 2 because you have to check on what you have at the bottom there, and you need that derivative. You work towards that derivative. Alright, thank you guys. This was a long session. Hopefully the next one will be very short. See you again next time. Goodbye.